Welcome to Ask and Learn.
Let's first determine whether this series is absolutely convergent. So we'll take the absolute value of this term here. And that leaves us with just 1 over natural log of n. So the question now is whether this new series converges. And so here I would use the comparison test. We have 1 over natural log of 2. This is, natural log of n is bigger than or equal to 1 over n. And the reason for this is that n is bigger than or equal to, but really bigger than, natural log of n. And in our case, n is 2 or larger. So this justifies this over here. And we know that the series 1 over n diverges. This is the harmonic series. Or you could also use the p-test with p equals 1. So since our term up here was bigger than or equal to n, then by the comparison test, our series starting at 2, 1 over natural log of n diverges. So that's using comparison. So here we conclude that it's not absolutely convergent. Now we'll determine whether it's conditionally convergent. So this is asking whether or not the original series over here converges. So you see that this is an alternating series. So that suggests we should go ahead and use the alternating series test. Let me go to the next page. So I have my sum here from 2 to infinity, negative 1 n, natural log n. So let's use alternating series test, AST. So here we define Bn to just be the absolute value of this term over here. So that's 1 over natural log of n. And notice that this is bigger than or equal to 0 if n is bigger than or equal to 2. Coming from over here, the lower bound of the sum. So we have to check a few conditions here. We need that the Bn's are decreasing. We'll check that later. Let's first just check that the limit is 0. And the denominator goes to infinity, so that limit is 0. We need that the Bn's are decreasing. So we would want to show that this is less than or equal to this. And this is equivalent to 1 over natural log n plus 1. And then we have natural log n. And this is a true statement. Since we know that natural log of n is less than natural log n plus 1. And if you're not convinced why this is true, you could exponentiate each side and you'll end up with this. And we definitely know this is true. So we have that the Bn's are positive, that their limit is 0, and that the sequence is decreasing. So we conclude that the series is conditionally convergent.